This is for anyone that's interested in designing their own tubular or trellis frame. It's important to keep in mind the manufacturing or the processing method used to create your parts, because there are some small details that do make a difference. So here we'll take a look at the processing of steel tubes to see how we should model the cuts, especially where we want to join the tubes. You'll find multiple videos here on YouTube showing you how to create these cuts in your tubes, and they'll either refer to it as a notch or perhaps a coping. So for modeling the tubes, you can do it with a sketch and then convert it with this pipe feature. We can set the external diameter and then the section thickness. This seems to be the simplest way of modeling it in Fusion 360. I like to add an extra little detail which has often been missed, and this is coming from the perspective of mass production in industry. So everything is modeled to a nominal condition, but there are going to be tolerances. And to make sure everything fits every time, we take those tolerances into consideration in assemblies and fabrications. So a fabrication tolerance may be something like plus or minus 1 millimeter, so we can include a 1 millimeter offset when we copy this surface for reference. So here we're using the split phase tool on the internal surface of this tube, and we're using the offset surface of the connecting tube as the splitting tool. Essentially what this does is it makes a new profile on the surface that we can then select. Then we use the press and pull feature, and this is essentially like an extrusion, and it's going to be an extruded cut. And this simply gives us a very clean coped edge. And then you'll see the difference we have here is we have a small offset between the end of this tube and the connected tube. We'll now repeat the same for the bottom, and then we'll move on to the lower tube. Now often you see people model these tubes to come together, and then they will join them with a chamfer, and this would be done to represent the weld. I think the problem you might have with this is that you may have two bodies joined together with a chamfer, and if you were to do a structural analysis on this part under load, it may treat it as if it's a single body. So I'll be uploading another video soon to show how we would connect these tubes with welds, and in a way that the welds would be treated as separate bodies. And this would be the same methods used in industry when we're doing a structural analysis on our frame in order to prove the concept. So now we've come to the more complicated cut. I would like to show two methods for this part. The first one will be using a similar method as previously used, and the second is the method used to model the tubes when designing the Triumph 660 platform frames. Now we did use CREO at Triumph, but this method can still be used in Fusion 360. So as before, we use the offset surface to split the face of the internal surface of the tube. So one reason why the profile here is important is because when these tubes are being manufactured, they may be on a CNC machine. The laser may only have one axis, which means that the cut will always be perpendicular to the surface, which is exactly what we have here. When we inspect it though, we'll see that the external surface actually comes almost into contact with the tube, and that's because in this case the surface that contacts the tube first is the external surface, not the internal surface. So we need to consider both when we do this. So again, we do the same thing. We use the offset surface to split the face of the external surface, and then we use the press and pull feature to remove that section as well. And here we can see we have the 1mm offset for the full cut of this tube. And this will be the final condition before adding the welds. As I said, I'd now like to share an example of how we modeled the tubes at Triumph for the 660 platform. So typically we model everything in surfaces before it becomes a solid model. So here I set the diameter of the tube to 20.8. This is our internal surface. Coming to the connector tube, we take the 1mm offset external surface and we would trim that away from our internal surface. Now if we offset this surface to get our external surface, we'll see that interference again on the external surface. At this point, we trim that away using the offset surface again. And then we can simply offset that external surface with a thickness of 1.6mm to get our 1.6mm tube. And we'll see we have the same result at the end of the tube as the previous method. So I hope you found this useful. In the next video I'll be going over the methods used to create welds.